Now let's move on to the Gumbel copula. Similar to the Clayton copula, the Gumbel copula depends on a single parameter, theta. This parameter can be named in various ways, but the key point is that the copula is governed by a single dependence parameter. Here, I have named it the same way as in the Clayton copula, but its range is different. For the Clayton copula, theta must be greater than 0, whereas for the Gumbel copula, theta must be greater than or equal to 1. In the left panel, we currently see theta set at 2. Below, we have the formula for Kendall's tau, but once again, Spearman's rho is not available in closed form. Instead, Spearman's rho is computed using stochastic formulas. As before, we also have lower tail dependence and upper tail dependence. A crucial difference between the Gumbel copula and the Clayton copula is that the Gumbel copula is designed to model upper tail dependence. Because of this, in the upper horizontal bar, we see that upper tail dependence is non-zero, while lower tail dependence is 0. This remains unchanged, regardless of the value of theta, since the Gumbel copula does not measure lower tail dependence. In this case, just like with the Clayton copula, as theta increases, the density in the upper tails, where U1 and U2 are close to 1, increases. At the same time, the values of Kendall's tau and Spearman's rho also increase. However, with LTD remaining at 0, only upper tail correlation continues to grow. Now, let's increase theta to a sufficiently high level. Looking at chart A on the left, we can now see that the peak in the upper right corner, where U1 and U2 are close to 1, is significantly higher than before. On the right plot, chart B, the entire space appears to have a uniformly low density level. However, the left plot, chart A, shows a ridge along the diagonal from point 0, 0 to point 1, 1, indicating that some density variation is still occurring. Although this is not clearly visible in chart B, we can still see small, bright yellowish spots in the upper right corner. These correspond to the sharp peak from chart A. Additionally, with an increase in theta, we observe that Kendall's tau and Spearman's rho have grown significantly. However, lower tail dependence remains unchanged, since this copula does not model lower tail dependence. Instead, upper tail dependence for variables x1 and x2 has become much stronger. The upper tail dependence is now close to its maximum value.